All right, here we have lesson 5 using sine and cosine ratios to calculate lengths. In the previous lesson, we were using sine and cosine ratios to calculate the angles. So let us review the steps on how to do that. When we are finding sides in a right triangle using sine or cosine ratios, we use the following steps. We first need to set up the trigonometric equation and then solve for the unknown side. So here we have an example. Determine the length BC, so as labeled here, to the nearest tenth of a centimeter. So in this case, if we're solving for this length here, we are orienting ourselves from the angle of 50 degrees. We have the hypotenuse, and we are solving for BC. So in this case, we think which one would we use? That uses adjacent and hypotenuse, and that one would be the cos ratio. So we have cos x is equal to adjacent over hypotenuse. Solve for those values. So we have cos 50 is equal to x over 5.2. We now want to isolate the variable of x on its own. So I'm going to multiply by 5.2 on both sides. Cos 50 multiplied by 5.2 gives a value of 3.3 centimeters. And that is the length. Now it is asking us to determine the length of AB. So I'm going to call this value y. In this case, I am given the hypotenuse. I'm going to solve for the opposite length. So I'm going to use the sine ratio. So sine theta is equal to opposite over hypotenuse. Sine 50 is equal to my value of y, which is unknown, and 5.2. I'm now going to isolate the variable of y, so I'm going to multiply by 5.2 on both sides. Sine 50 multiplied by 5.2 gives y a value of 4 centimeters. So I now have the two sides solved for this triangle. Example 2. Using the sine or cosine ratio to determine the length of the hypotenuse. So in this triangle, I say that's a right angle. I need to solve for the length of the hypotenuse based off angle E, that is 55 degrees. So I'm going to use sine theta opposite over hypotenuse because I want to solve for ED, and I'm given the opposite, so I'm using sine. Substituting the information that I know that sine is 55 degrees. It is equal to opposite, which is 6.8 over the value of DE. I now want to solve for DE, so I'm going to swap these two values here. Therefore, DE is equal to 6.8 divided by the sine of 55. Punch that into the calculator to give you a value of 8.3 centimeters, ensuring that you have your units. Triangle ABC, solving for the hypotenuse. I find my angle here, angle 41. I want to find the hypotenuse, and I am given the adjacent. So in this case, I'm going to use cos adjacent over hypotenuse because that's the information I'm given in the triangle. I'm going to substitute the information that I know. So cos 41 is equal to 9.7 divided by the length of AB. When I have an unknown variable on the bottom, I just need to swap. So AB is equal to 9.7 divided by the cos of 41. Punch that into the calculator, I get 12.9 centimeters. We're solving an indirect measurement problem. So here we have a surveyor made the measurements shown in the diagram. How could the surveyor determine the distance from the transit to the survey pole to the nearest hundredth of a meter? So I see that I have a right angle triangle. So across from here would be the hypotenuse. This angle is 67.3, and I'm given the adjacent. So if I have the adjacent and I'm solving for hypotenuse, I'm going to use the cos ratio, which is equal to adjacent over hypotenuse. I'm going to substitute the information that I know. So cos of 67.3 is equal to my adjacent, which is 20.86, over my value of x is where I'm going to represent my hypotenuse. When you have an unknown variable on the bottom, you simply swap them. So x is equal to 20.86 divided by the cos of 67.3. Punch that into a calculator. You get 54.05, and in this case, it's measured in meters. Watching for your units. Final example, example 4, using sine and cosine to solve a triangle. So here we have a triangle, and in the question it has provided us with the degrees and the lengths. So I am going to label this triangle x, y, z. It tells me that z is a 90-degree angle, and that side z, note how it's with a lowercase letter, is equal to 26, and that should say meters. It tells me that angle x is 56 degrees. Now it wants me to solve the triangle. So in this case, solving the triangle means all three sides and all three angles. So first, I'm going to start with solving for side x, and here is side y. So using side x, which is opposite over hypotenuse, that's using sine. So sine theta is equal to opposite over hypotenuse. Substituting the information that I know, sine 56 is equal to x over 26. I need to isolate my variable x, so I'm going to multiply by 26 on both sides. 26 multiplied by sine 56, the value of x is equal to 21.6 meters to give me side x. Now I can use cos to solve for side y. So I have cos theta, is equal to adjacent over the hypotenuse. I substitute the information that I know. Cos of 56 is equal to my value of y, because that's the side I'm going to solve for, the adjacent, over the hypotenuse of 26. I want to isolate the variable and have y on its own, so I'm going to multiply by 26 on both sides. 26 multiplied by cos 56. The value of y is 14.5 meters. To have now solved for this last length. And my final task is to solve for angle y. I can use the 180-degree rule, so all triangles add up to 180 degrees. I know that angle z is 90 degrees and angle x is 56 degrees. That remainder is 34 degrees for angle y. I have now solved all three sides and all three angles in the triangle. And that finishes lesson 5.